Hello there and welcome to a new lesson. In this one we'll start off with the coins. So first of all, here in the sprites folder I will right click, create sprite, and I will select and I will create here the SPR coin. Then I will also need the OBJ coin that I will create over here, OBJ coin. Fortunately, here in this sprite, we don't have more animations, okay? So we are able to just import over here the coin image, and we don't have much things to do in terms of the animation because it is just one frame, so we don't have to animate it unlike we did with the player. We can just select this over here, middle center, and that's going to do, because this just makes positioning a little bit easier. Now let's also load in this sprite in the corresponding object. And basically the main functionality of the coin, the main event, will have to do with the collision with the player. Basically, when the player collides with the coin, we have to do some stuff. So I'm going to add here that event. So we'll go add event, collision objects player, okay? I will delete here these descriptions. And before doing more things, firstly I need some variables here. So over here I will create them. First of all, I need the level, okay, the current level, and initially the player is going to be on level 1. Then we are going to have a level coins collected that is going to be 0 by default. These are going to be basically the coins that I specifically, or well, that the player collected specifically in the level that it is playing. So for example, in level 1, the level coins collected could be firstly 0 and then 1. Once that level 1 is completed, we would be in level 2. And when any level is completed, level coins collected is of course reset to 0, because in that new level the player has collected 0 new coins. So in level 2 the player will start off with 0 level coins collected, then it could collect 1 coin, then when it collects the second level coins collected, we will once again increase the level and reset the level coins collected. I know it may sound a little bit complicated, but then you will see that it is much easier, and we will see this in action in just a few seconds. And also I will need to have in count the total coins collected. And yes, these ones are going to be the ones that, in spite of the level, are always going to have the exact number of coins that we have collected throughout the game session. So these will never be reset, unlike the level coins collected that are going to be reset when the level is reset. Or well, actually when a new level begins. So now in our coin collision, we can do some stuff. So first of all, if there has been a collision between a coin and the player, it means that the player, okay, have collected 1 coin, 1 level coin. So level coins collected plus equal 1. And then also it means that the total coins collected should also be increased. And after updating both variables, I have to determine if the level should be increased or not, basically if the level has been completed or not. And how the game logic of this one works is that if the level coins collected is equal to the level, then it means that the level should be increased. So if the level, okay, the level alone is equal to the level coins collected, so for example, as in the introduction slides, level is 1, okay, then the level should be increased if the level coins collected are 2, for example. In that case, it means that we have successfully passed the level. And what would happen in that situation? That, first of all, the level should be increased, and as the level has been updated, the coins that the player has collected in that level are basically 0. And now after doing all this, I will do instance destroy, okay, to basically destroy the current coin once it was collected. Now I know this may sound a little bit complicated maybe to understand at first, and also we can't preview it right now because we have no coins in the game. So we have to create the coins spawner, and to do this I will create here a brand new function that is going to be spawn coins. That, by the way, I will call at the beginning of the game, because as soon as the game starts we should be able to spawn some coins, because if not the game is going to be empty. And also therefore, if the level is passed, once the level is passed, we also have to spawn some coins. Now first of all we have to determine the number of coins that we want to spawn, and this number of coins will be the level. If we are in level 1, there should be 1 coin available to collect. If we are in level 2, there should be 2 coins. If we are in level 3, there should be 3 coins. So how we do this is by using for loops, okay? So I will create it over here, and this always has an index variable that is usually called I, initialized at 0. Then we have the condition that is basically going to be if I is smaller than level. So here we are doing this of, okay, spawn as many coins as the level, okay? And finally, what is going to be happening after each iteration in each loop. And basically, as usual, this is basically increasing I, okay? So basically, by creating this for loop, we will ensure that anything that we write here is going to be run as many times as the level, okay? So if level is 3, what we write here is going to be run 3 times. So first of all, what I want to do is to determine which are the positions that the coins may have. So of course I want to always make sure that my coins are instantiated inside of the room. However, what could happen is that, for example, a coin is instantiated like super far away from the player, super at the bottom, super at the right, super at the top, super at the left, super at the bottom. So it could be a good idea to have some kinds of margin, okay? You will see actually this when we get to spawn the coins a little bit better, I mean. But initially we are going to be having a coins margin X of 50. So this means that instead of being able to, for example, spawn a coin here, the coin should always have 50 units of space. So maybe the coins will be able to start being drawn from this space over here instead of to the right edge of the screen. So this will ensure that always our coins are inside of the player view. And the same thing I will do with margin Y, that in this case is going to be 150. Why? Because I'm going to be having also a user interface here on top that will say the number of coins that I have collected and the current level. So I don't want to have any coin that is spawned in that section where that interface is shown, because if not, the coin will be displayed behind that user interface and it could be difficult for the player to actually see that there is a coin over there. So that's why the margin is a little bit bigger. And now I'm going to create 2 variables for the actual coin X and coin Y. For coin X, and to create this randomness, you are going to use in random range. Basically, you provide firstly the minimum and the maximum. The minimum for this is going to be coin margin X. And actually, I will call this one coin instead of coins. Okay, exactly like this. Because what I want to do, we are right now in the x-axis, so I don't want to start off at 0, I want to start at 50, that will be something like here, and I want to end in room height, okay, minus the margin, okay, so I would have it somewhere like here. So the maximum, instead of being room width, I will do room width minus coin margin x. This will ensure that we always have this margin of, in this case, 50 units every time we spawn a coin. And we'll continue with this system in the following lesson. Hi there and welcome to a new lesson. In this one we are going to continue with the spawn coins function, okay? So we have already created the coins margin, sorry, and also the coin X, and now we have to define the coin Y. So I will create it over here and it's going to actually be quite similar to coin X. The minimum value for it is going to be coin margin Y. Okay, so basically instead of being 0 that would be at the top, it's going to be coin margin Y, that maybe could be something like here, and the maximum value to it, it should be room height, okay, that would be at the bottom, minus the coin margin. Okay, so we would also leave some space between the actual bottom of the screen and the margin, okay, that we are stipulating. So here the maximum is going to be room height minus coin margin Y. And finally, after doing all this, I have to actually instantiate the coin. So to do this, you write instance, create layer. You firstly provide the X, okay, that it's going to be the coin X variable we've just created. In the Y, we'll use coin Y. Then in the layer, I will just use layer, that will be the current layer. In this case, the instance is layer, basically this one, and that's okay because the player is already there. And finally, the coin, that is going to be obj coin. So now when we click play, we can go ahead and collect this coin over here, and now we get 2 coins because we're in level 3. In level 3, we get 3 coins. Then here we get 4 coins, and as you can see, we never get coins super spaced out. Even something that you can do to try out this is to, instead of the condition being this one, you can increase it much more. For example, if you want 100 coins, you can spawn 100 coins, and there you see the margins that we have created. So you would also be able to play around with the margins and adjust them as you want. Remember, we are leaving here bigger space on the top because here we'll have some text displaying. But well, just for now, we have to make sure that the condition is correct. Something else that you may have noticed is that when we play, well, the first coin, at least on my session, is on the bottom right, let's say. And the other 2 are in these other positions, okay? And then the other 3, if I do not remember bad, were exactly right there. And if we play again, basically if we are in different game sessions, you will see that, well, you will get the exact same results, even though they are being randomized because not every single coin is being instantiated at the same point, at the exact same point. Basically what we are getting out of the randomness is the exact same thing. So to avoid this, there is a function that is super easy that is called randomize. So randomize, what we'll do here on the create event actually, so as soon as the game starts, at least the game room, the function sets the seed to a random value. And basically the seed will determine the values that we are getting out of every random generation. And if we, in every single game session, we are randomizing this seed, it means that we'll always be getting different results. Okay, it is much easier. I just try to explain a little bit more what seeds are, but when you do this now, you will always get different results. There we got different positions for the coins. Now you will see that I will get different positions. For example, for the first coin, I got it on the bottom left. In the second session, I got it, well, once again on the bottom left, but it is a little bit more to the top of the screen. Now in the third game session, I got it in a completely different space. And well, as you can see, it is always changing, okay? And well, by the way, here I got 2 because the coin was instantiated exactly like at the center where my player was able to collide. But well, that is something that it's not always going to be happening, okay? So now with this lesson is finished. Hello there and welcome to a new lesson. In this one, we are going to be implementing the coin particles. So to create them, I will go inside of the obj player, and in the create event, I will declare the different variables that particle systems need to work. So over here, I will create them. So particles, in order to be created correctly, they need two things. First of all, a particle system that you create exactly like this. And also you need a particle type that you create like this, okay? So basically the particle type is what you actually modify, okay? It's like the particle asset that you create, in which you modify the shape, the size, etc. So the first thing that we have to do is to modify this particle type. And there are actually lots of things that we have to do. So for example, first of all, we may want to modify the particle type shape. Okay, so sorry, part type, because also when you type this you will see that there are dozens of methods that you can use to modify your particle type. So in all of these kind of methods, you firstly provide the particle type and then the different parameters that you want to modify. And for the shape, you would do pt shape, and here, well, you have tons of shapes that you can use. In this case, I will use a star basically because it does look quite interesting. And after doing this, I will also set up the lifetime of the particle. I will provide the particle type, and the lifetime you can provide a minimum, okay, and a maximum. And I will just make sure that all my particles live for the exact same time, just to make the effect constant, okay? So every time the particles are emitted, the effect that you get, at least in terms of lifetime, is the exact same one, because if not, sometimes you may get particles that live for more time, and other times you may get particles that live for less time. So to make sure that they always live for the exact same amount of time, both in the minimum and maximum values, we provide the exact same one. Then other thing that you may want to modify is the part type size. Okay, and for this you do have more things that you can modify, not only the minimum and the maximum. But by the way, the minimum is going to be something like 0.3 and the maximum 0.5. Then you also have the size inker and the size wiggle. So the inker, as it says here, basically allow us to determine how much the particle should increase or decrease in terms of size over time. Okay, but here I want to keep my my size always constant. I don't want to be modifying it over time, and I don't either want to add or subtract randomly from the particles. So both of these parameters are just going to be 0, as I don't want to be modifying the size over time. So then I will also want to modify the speed of the variable. And for the minimum speed, I will provide 2, for the maximum 3. And for the speed inker and speed wiggle, once again 0, because I want to keep it constant. I don't want to be randomizing it or adding and subtracting over time. Now, in terms of the direction of the particle, what I want to do over here is to provide a minimum direction of 0 and a maximum direction of 180. Okay, so this will create some kinds of like explosion effect, like emitted in some kinds of circle or line like this, as if it were half of a circle. So that would actually look quite good once we see it. And once again, we can provide the inker and wiggle. So for both, I will just put 0, as I want to keep it constant. Now I also want to add gravity to my particle. Why? Because I want that when the particle is emitted, I want it to fall down to the ground. So to do that, we just have to add gravity to the particle. Okay, as in real life, if you drop an object, it is going to fall down. So here we want to do the same thing, but with particles. Once they are emitted, I want them to fall. So I will provide a particle type. And here I have to provide the gravity amount. Okay, so how much gravity we are going to be having, that's going to be 0.35. And then we have to provide the gravity direction. And I want to make my direction down. Basically, I want to make my gravity go down, and how direction works in GameMaker, as we have explained while we were modifying the direction of the player, 270 degrees is down. This means that the direction here should also be 270. Now, I also want to modify the alpha of it. So you will realize that you have three possible functions. Basically, alpha 2 will allow you to set a start alpha and an end alpha. So it's going to allow you to change the transparency of the particle over time. So what I would be able to do over here is to start off my my particle at an alpha of 1, basically at full transparency, and as time goes by I would be able to decrease it until 0 so that it can't be seen. And finally, I can also provide here a color for it. So in this case I will use color mix, and this variable will take two colors and will basically blend them, okay? So for example, it will try like to create some combinations between them. So if you put one color to be orange and the other one purple, it will try to blend them to create colors that could be created if you actually mix them in real life with a paint. So for example, over here, I will provide color 1, for example, C red, and color 2, C blue. So I will always have colors going between the red and the blue, and this will actually give the particle a little bit more dynamism, okay? After now creating all this, by the way, I understand that this could be so much data, but well, writing one line, testing what it is doing, it will just take too much time. So for you to understand this a little bit better, for example, some parameters that could be difficult to understand could be the direction, okay? What happens if you change the minimum and the maximum direction? Also, you can play around with the alpha, with the colors, but well, if we were actually playing around with every single value over here, this lesson would actually take much more than needed. So after you actually have the particle created, we will need to emit it. We want to emit this particle when there is a coin collision. So over here, I will create it, and to do this, you would call the particles create. You will provide the particle system. Then where do we want to spawn these particles? Basically the current X and Y of the coin. Then the particle type, that would be the obj player.particle type, and also the number of it, but just make sure here to pass the corresponding variable and the number, okay? And something like 10 particles is going to be just fine. So now when we collect a coin, you are going to be seeing these amazing particles that actually add a lot of dynamism, of visual effects to the game. Not only this, but also in the player, we must add the cleanup event, in which we need to do exactly that, to clean up the particles. So here we're going to be doing part system destroy and part type destroy. Basically, this event is called when, for example, the game is restarted. So every time that the game is restarted, we should always have the good practice of cleaning up both the particle systems and particle types, just to prevent us from some kinds of memory leak. As this is a pretty small project, we don't have that many particles. Even without these lines, we wouldn't be facing any error, but well, it is a good practice, because then in bigger projects we must use this technique to make sure that we keep performance, okay, even though we may have more particles and more things in the game going on. But well, now with this, the particles are finished, and therefore the lesson 2. Hi there, and welcome to a new lesson. In this one, we're going to be creating the coin animation. Animations in GameMaker are called sequences, okay, so we have to create a new one. So I will right click, create, and here we'll select sequence. I will call this one seq_coin. And well, we're going to be having this new interface. It is actually easier than it may seem, because I will here in the track panel just select the coin sprite, and here I am able to animate it quite easily using the GameMaker animation tools. So always when we create an animation, we have to have already an idea of what exactly we want to do. In this case, what I want to do is an animation that will both scale in the coin, and at the same time that the coin is being scaled in, I want to change its transparency. Okay, I just want to fade it out. So now that I know the effect that I want to create, I have to think of the properties of the sprite that I want to be modifying. If I want to scale it in, that's going to be the scale, and if I want to modify the transparency, that is going to be the color. So having these two things in count, I will click over here on the add parameter track, and I will add, for example, here the scale track, and I will do the same thing but with color multiply. Now at the beginning of the animation, basically on the frame 0, I will key the initial values. Okay, so I will create a new keyframe of both. So basically the keyframes are then the different points that are going to be used in order to create the animation. Okay, so are going to be the base points, let's say. And then at the end of the animation, that as you can see, lasts for 60 FPS. I will go to the 60th frame, and over here I have to say, okay, what do I want to do once as the animation plays? As I explained, I want to change the transparency of this, so I have to modify the alpha. Okay, and as you can see, even the value was keyed automatically. And then I also want to change the scale to 200 in both axes. Okay, just to make it a little bit bigger. And now I will also key this value. So now we can also play the animation, and there we are going to be having it. But well, it seems that here the scale was not keyed, so I will key it once again over here, and let's try once again. For some reason here the keyframes are working a little bit weird, so I will just delete this track or these last keyframes. Okay, and well, once again here I will enable this keyframe. Well, the thing is that at the beginning, for some reason, it was also modified to 200. So there I have the first frame on 100 and the second frame on 200. So now it is working as it should. Okay, now it is playing a little bit slowly, so here in the frames per second I will increase it to something like 175. Okay, so it's going to be playing much faster. Okay, now with this sequence is finished, but we have to actually implement it in the game. So to do this, we are going to be needing a new layer, an assets layer, and I'm going to be renaming it sequences, and I will put it behind the retry button layer. Okay, because the animated coin should not be displayed basically on top of the retry button. Okay, and now we have to also think of where do we want to be playing this sequence or animation, and basically that will be once the coin is collected. So before destroying the instance, I will create this sequence, and to do this it is quite simple. You just write layer sequence create, and here you provide the layer ID, basically the layer that we have just created, sequences, the X and the Y position, that would be our current X and Y, because we want to play this sequence at the exact position at which the coin is, and finally the sequence itself, that is seq coin. And now not only do we have those amazing particles, but also this animation that is played whenever we collect a coin. So indeed both the particles and the animation add a layer of visual effects to the game that are outstanding. Okay,